Hello, this is Mr. Hannon. Welcome to What Format. Today we're going to go over perfect square trinomials. Now there are two patterns for these. I'm going to, again, like similar with difference of squares, use a and b. A squared plus 2ab plus b squared. And notice this is the same, a squared minus 2ab plus b squared, the same except for this minus. See, the terms are the same, just one here, this is a plus and that's a minus. Well, why is that? Well, this factors to a plus b times a plus b. That's why the middle is a plus. See, a positive times a positive, b times b is your b squared. But now notice I have ab, not once, but twice, and they're both positive, so plus 2ab. So then I can write this as a plus b squared. See, a perfect square trinomial. I took a binomial and I squared it. That's how I get here. So factoring, I have to get back to a binomial squared. Here, because it's minus 2ab, the only difference is now instead of a plus b, it's a minus b, a minus b. See, minus b squared, minus b times minus b, there's your plus b squared. Then you have a minus ab and a minus ab twice. So there's your minus 2ab. It goes to a minus b squared. Here are a couple examples. So how you factor these is you check. Okay, square root of 4x squared, 2x. Square root of 25 is 5. Since this is a plus, we're going to try plus 5. Okay, now you check. You take this product, 2x times 5, and you double it. Well, 2x times 5 is 10x. 10x times 2 is 20x. That makes it a perfect square trinomial. Okay, this product is always, or this number, I'm sorry, is always the double the product of these two square roots. Now that's a mouthful, isn't it? So first thing we do is we take the square root of this, we take the square root of that. Then we take the product of that, we multiply them together, and we double it. If that's your middle term, it was a perfect square trinomial, and then there you go, 2x plus 5 squared. And you know this is a plus because that was a plus. So now over here, if this is a perfect square trinomial, we're going to have a minus in the middle. Okay, square root of 9x squared is what? 3x. Square root of 16 is 4, and it would need to be minus 4. Okay, now we need to check. 4 times 3, or negative 4 times 3, negative 12x. If I double negative 12x, sure enough, negative 24x. That is the pattern, okay? Because when you, as you can see, when you square binomial, this product here, this and this, they're going to be the same thing. And when you have two of the same number, 3 plus 3, it's the same as 2 times 3. 4 plus 4, same as 2 times 4, and so forth, all the way up there. That's why this is, see, double the product, 2 times ab. And notice a is the square root of a squared, and b is the square root of b squared. So that's why I took the square root of this and the square root of that, multiply it together, and double it. See, multiply it together, a times b, and double it. And if that's your middle, then it's a perfect square trinomial. Now, it doesn't always end up like that. You can have what looks like perfect square trinomials, okay, and it, like, so you got an x squared here, and I got a plus 36, so you're thinking, oh, square root of x squared is x, and that's a 6, but instead of a 12 in the middle, you'll have, like, say, a 13x. So now all of a sudden, you didn't get a 12, see, x plus 6, 6x doubled is 12x. And since 12x doesn't match 13x, that means this was not a perfect square trinomial, even though the first term, your ax squared and your c were perfect squares. So just because they're perfect squares doesn't always mean they're perfect square trinomials. You always have to follow through and check that. You got to check this product, okay? 6x times 2 is 12x. Since 12x doesn't match 13x, it's not a perfect square. Now, of course, if they change that, right? And instead of that being 13x, that was 12x, then that would have matched and it would have been a perfect square trinomial. So this is the part where Algebra 1 really starts to pick up. A lot of the things you've done in the past start coming back, but now they're in combination. And since there's so many variations of them, you have to check for all these little things. If you've forgotten these things or aren't used to slowing down and thinking through a problem, big trouble. You need to start, if you're not good at it now, you need to practice and get good, because it only keeps getting worse from here. Anyway, this is perfect square trinomials. This is going to be very important because pretty soon, one of the ways of solving quadratics is completing the square. We also use complete the square to turn a standard form polynomial into vertex form. Okay, so standard form into vertex form, or to get into, if it's a function, general form to standard form. Okay, it's still the same format, just different names. That's something you got to watch for. Normally, standard form, ax squared plus bx plus c, vertex form, a times x minus h quantity squared. And you'll see when you have something times that squared, what we did is we had to factor it into this. Okay, so completing the square will make use of this pattern that you see here. So this doesn't go away, it only keeps getting more and more. So hopefully you practice this. And an easy way to get good at this is just take a lot of binomials and just start multiplying. Just practice, multiply 100 of them. In fact, you know, you start with x plus a number, x plus a bunch of numbers all the way up to 10. Or x minus a bunch of numbers all the way up to 10, and then put a 2 in front of the x, then a 3 and a 4, and you just keep going and multiply until you start to see the pattern. Once you see the pattern and it starts to click in your brain, it won't be as scary, and you'll be ready to kind of move on to the next step. Anyway, this is Perfect Square Trinomials. This has been Mr. Hanna with What the Format. Thank you for watching. Happy math.